Okay. All right. So this is the week of August 21st to August 25th. This is what we're covering. Module 1. How do we characterize the graph? So we are going to get into, thank you. We're going to get into domain range, okay, domain and range, and behavior, positive and negative, increasing and decreasing, and average rate of change, okay? And then we're going to get into how do we write out those intervals. If I ask you, where is the graph positive? How do we actually write it out? What are we talking about? And so on and so forth. So here we go. So lesson 1.1 is on domain, range, and behavior. Okay, just those three things for now. Okay, this is how we characterize our graphs at first. Okay. So an interval is a part of a number line without any breaks. A finite interval has two endpoints, which may or may not be included in the interval. An infinite interval is unbound at both ends. So this is the way that we can write. This is the way we can write out an interval. If I ask you, hey, what is the domain? Or what is the range? Or what is the end behavior? This is how we do it. If the range or the domain, let's say, for example, we have a number line here, right? And there's that 0, and here's the 2, and it looks like that. Right? You all seen that number line before, right? How do I represent this interval here? Yeah, it's 2 to the infinity, right? But the first way we do it is we use the set builder notation. Okay, the set builder notation is we have these fancy parentheses, right? Brackets. And it goes x such that x is greater than 2. Because I'm interested in everything greater than 2. Right? So here, what this line represents is it goes on forever and ever and ever and ever. Right? And since that's an open circle, 2 is not included, right, in our set. Okay. All right, so that's set builder notation. Interval notation is a little bit different. That's what we're going to be focused on in this class is interval notation. So this one is the key one here. This one is the key one here. Okay. It looks like interval notation looks like a coordinate. There's two values separated by a comma. The left-hand side will represent your lowest value. So if we're talking about anything greater than 2, 2 is my lowest value, right? That it can be. And it goes on forever. Forever means that it's infinity. So it looks like a backwards 8. Yeah, and that's infinity. Okay. Since the value of 2 is not included, whenever a value is not included in our set, we are going to have parentheses. If it's included, we're going to have brackets. Okay? So I'll show you guys an example in my later thing, but infinity or negative infinity will always be parentheses. Because it's so big, we can't put a number on it. We can't put a value on it because it just goes on forever, right? So it's parentheses 2, comma, infinity, parentheses. All right. Questions on that? No? Okay. Let's say, for example, we have a number line here that goes from, here's my 0, 1, and it goes like that. Okay. Let's work with that one for now. Okay. In set builder, it's going to be with these fancy brackets, x such that x is what? What's my inequality here? Less than or equal to 1, right? Because in my closed circle, that means that that number is included, right? So you can actually put it here as well. That's a closed circle, and that's an open circle, okay? Parentheses is not included. It's an open circle. Brackets, it's included, and it's a closed circle, okay? In interval notation, right, we have 2 blanks. Okay, what's the biggest number that this can be, this problem, or this interval? Anybody besides our, yeah. 1, right? Okay, so on my right-hand side, which represents the largest number, it's going to be 1. On my left-hand side, does it ever stop? It never stops, right? It keeps on going on forever on the negative side. So that is negative infinity. Okay, so there is my interval notation, but I just need to put brackets now or parentheses, right? Since negative infinity is so big, it's always going to be parentheses. Okay. 1, is that number 1 included or excluded? It's included, right? So whenever it's included, right, we're going to use these brackets. There's a bracket around 1. Okay. Questions on that? So that's how we find, or that's how we represent intervals. Okay. All right. So here we have 2 more examples. And let's try this one. It's a finite interval because they have 2 endpoints. We know exactly where the endpoints are, right? That's what it means by finite. So an inequality, what is my inequality here if x is my variable? This one's really simple. I don't know if anyone has said this before. If we are talking about two finite points, right, that x can be, all you're going to be doing is this. Write x in the middle. Write the low point here, which is, what's the smallest value? -3. Write the highest point here, which is 2. And then put less than sign. That's it. Because you're saying -3 is less than x, which is less than 2. Is this correct? 1 for yes, 2 for no. 1 for yes, 2 for no. This is correct. This is the inequality that represents my finite interval. Raise it up high. 1 for yes, 2 for no. 1, 2, and stem. 1, 2. So I see a 1 or 2. 2? 2? You think I'm wrong? Always. 1, 2. The majority of them are 1s. Wow, I'm wrong. So you twos are correct. You twos are correct. I am incorrect. Why am I incorrect? Yeah, it's supposed to be less than or equal to. Okay, remember, because these circles are filled in, right? They are included in that set, right? That means that we have to put less than or equal to. Okay? Set notation, once you guys get the inequality, set notation is simple. All we're going to be doing is we're going to be adding these fancy brackets, x such that. That's all we're going to be adding. And the rest you guys already got up here. So I'm just going to rewrite -3 is less than or equal to x, which is less than or equal to 2. That's your set notation. Okay? In red is what we're adding to my set notation. All right? How about interval notation? Besides you. Thank you, though. What's my low number? What's the smallest number that this can be? -3. What's the highest number, or what's the largest number that this can be? Kara? 2. Right? Is -3 included or excluded? Included, so it's going to be bracket. 2 is included or excluded? Included, so it's going to be bracket. That's it. Okay. Questions on that? No? Let's try another one. Here. -3 and 2, same numbers. So to my inequality, I'm going to write x in the middle. I'm going to take my low end, which is -3. Take my high end, which is 2. -3 is less than x, which is less than 2, right? Less than or equal to 2. Okay? That's my inequality. Questions on that? Pretty simple. Set notation, okay? We have these brackets, fancy brackets, x such that -3 less than x less than or equal to 2. Yeah, copy paste. Interval notation, put that comma there. What's my low end? -3. What's my high end? 2. Is -3 included or excluded? Excluded, so it's not included. So whenever it's not included or excluded, it's going to be parentheses. 2, included, excluded. Included, so it's going to be bracketed. Okay? Please take, oops. Okay. Any questions on these first two? No? Okay. Next set of examples I'm going to tell you to do. Fill this one out. And we will come back after this. Okay, let's talk about this. Complete the table by writing the infinite interval shown on each number line. So the inequality here would be what? The first one. Go ahead, Anna.
X is less than 2.
X is less than 2. Like that? Yeah. Yeah. Final answer? Okay. Andrew. Less than or equal to 2. Okay, because it's circled, right? Okay. And then set notation is simple if you got the inequality. X such that, fancy brackets, X is less than or equal to 2, right? Interval notation, what is my high end? What's the largest number that this can be? In this interval, 2. What's the low end, or what's the smallest number this can be? If it goes on forever in the negative direction, it'll always be negative infinity. Okay? And since negative infinity is so big that we can't grasp it, it's going to be parentheses. 2 is 2 included or not included? Included, so we bracket. Okay? Inequality here on the next one, X is greater than 2. So here in my set notation, it's going to be X such that X is greater than 2. Interval notation, it's going to be my low end is 2, high end is infinity because it goes on forever. And it's parentheses, parentheses, because 2 is not included because it's an open circle, right? So here, parentheses is not included. And it's not that. It's open circle. And then brackets are included. And it's closed circle. Okay. Sorry about my handwriting there. All right. Questions on this? You guys got it? Yeah. Okay. I want you guys to get into groups and figure out 1, 2, and 3. Okay? These are the answers that you guys should have or close to it. Okay? I went around and checked number 1A, which most of us got. That's the key thing to kind of get from this. Okay, all real numbers this is a symbol for all real numbers. Just know whenever you see that, that means all real numbers. Okay. All right, and then you guys can read through the rest. All right. Questions on 1 through 3? No? Okay. bit is end behavior. Okay, end behavior, I always like to put it this way. Okay, if your life, right, your life was the x-axis, right, when you were born, you're somewhere over here, right, all the way over here, correct? Because the x-axis is your life. Okay, so it's your age, right? And then all the way over here is like when you're an old grandpa or grandma, right? An old person. Okay. So the end behavior is, where does the ends of the graph look like? Or what does the ends of the graph look like? All right. Or where does it go towards? So the end behavior will always start off the same way. Okay. It'll be as x approaches negative infinity. Okay. Or this one means as x goes all the way over here, right? We're over here on my x-axis. Okay, if this thing was extended out, right? This part is negative infinity. Okay. Y approaches what? Where does y end up? Because this graph here, it goes on down all the way forever, right? Yeah, you guys see that? It's gonna shoot down and go down forever, correct? So y will approach negative infinity as well. Okay, that's end behavior. Okay. But this part here will always be the same. Okay. As x approaches infinity, y approaches blank. So this part here will always be the same. The only thing that does change is where my graph goes. Okay. And the next part is as x approaches infinity, or I'm all the way over here at this end, right, of the graph, right, of my x-axis. Where does my graph go? To negative infinity, to positive infinity, right? Because this graph will go on and go up forever and ever 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 and ever, right? So eventually hit, y would eventually approach positive infinity. Does that make sense? Questions on that? Yeah. Yeah. And I'll show you in a little bit. Hopefully I have one of those examples. Okay. And this part here will always be the same. All right. Okay. Questions? No? All right. We haven't talked about domain and range yet, but it's on here. It should be somewhat of a review for this class. For in general, domain means all possible x values. Range means all possible y values. Okay, and we're going to put those in intervals. And the last thing I want you to check out is look at end behavior. They already give you this part here, right? And we can also put down y approaches. Okay? That makes sense? Remember, your domain is all possible x values, so we're looking at the horizontal axis, right? The one that goes east, west, left, right, however you want to think about it. What is the what is all possible x values, or what is the domain in this graph here? So it, negative infinity to what? To positive infinity, right? Because there's no restrictions, right? Because it goes on forever that way, and it goes on forever that way, right? So in terms of your possible x values, I'm just going to put interval notation because I'm not going to mess around with those two. It's going to be negative infinity to positive infinity. And remember, with negative and positive infinity, it's always going to be parentheses. Okay. Your range. What's your range in this case? From 0 to positive infinity. Why 0? Do you guys see where the x is? I don't know if I can do that. I cannot do that. Yeah, the x-axis. There's a dotted line right there. You guys can't see it. There's a dotted line right here, right, on your x-axis. That's your asymptote. That means that it's never going to cross that line, okay? So it's never going to cross 0, all right? So on my interval notation, I know positive infinity is hard to grasp, too big to grasp, so it's parentheses. How about 0? Is the number 0 included or excluded? Excluded, right? So it's not included, so it's parentheses as well. Because whenever there's an asymptote, it will never cross that. It'll get close to it, but it won't cross it. All right? So as x approaches positive infinity, we're all the way over here at this end, right? That's positive infinity. What happens to my graph? It keeps on going up and up and up and up and up and up and up to positive infinity as well. How about over here? As x approaches negative infinity, so I'm over here at negative infinity, right? What happens to my graph? It just rides this out, correct? So where is it going towards? Where is it going towards? Somebody take a stab, or somebody take an educated guess on that. Kayla? 0. Yes. It's going towards 0. It's it's not ever gonna hit zero, but it's going towards it. Right? Okay. Any questions on this page? No? All right. Yes. Because your domain is all possible x values. So if you look at the horizontal numbers, right? This graph, let me clear it up. This graph, if you look at the horizontal numbers, it has no restriction, right? Because this graph will go from here all the way up and will go from there all the way to the left, right? The graph itself. We're looking at just the graph, right? But range represents my y values. This graph will never, ever, ever be below zero. If you look at the y-axis as my values, yeah, it's always going to be 0 and above, correct? That's why it's from 0 to infinity here. Was that her question? Okay, that was your question. All right. Okay. Try this one. Write the domain and range in interval notation and write the end behavior. Remember, the end behavior is, I'll start you guys off with the end behavior. As x approaches negative infinity, y approaches blank. And as x approaches positive infinity, y approaches blank. Okay? All right, so in this case here, write the domain and range. Your domain is all possible x values, right? These guys gotta stop. So all possible x values, since these guys have arrows, right? They will go on forever, correct? That's what those arrows mean. And since they go on forever, it's eventually going to hit all possible x values, right? Because there's no restriction here. So your domain is going to be negative infinity to positive infinity. Oh, that's so ugly. Okay, and there's going to be parentheses around the negative and the positive, right? Because it's gonna go on forever. Your range is a little bit different. Okay, your range is the representation of your y value. Remember, your y value, we're talking about the vertical line right there, right? The vertical value. Okay. So here, my high end, right? The highest it can be is 0. You guys see that? Okay, so I know that this is going to be 0. What's my low end? Well, it goes on forever, right? So it's eventually going to hit negative infinity. Correct? So at 0, it's going to be a bracket because it's included. And at negative infinity, it's going to be parentheses. Okay? As x approaches negative infinity, so I'm all the way over here now at negative infinity, right, on my graph. If I shoot it all the way across, then my graph here will eventually end up at negative infinity, right? Same thing goes for the positive infinity side, because it's going to shoot all the way down anyhow. So that's also negative infinity as well. Okay? So end behavior is saying, hey, where is it going? Where is my graph going? Just straight down. So it's straight to negative infinity. If it's straight up, then it'll be to infinity. At times, it will just level off to a certain value. And you just put that value there. Cool? Okay. That is that. Now, can we graph a function when the domain is restricted? When I give you a restricted domain, can you graph that line? Remember we did that review yesterday? Can we graph this line here from the domain of this? Yes, we can. Simple. Get the low end, plug it in. So I want to get x equals -2. So y equals 2 times -2 minus 5. Okay, I just plugged it into this function. So y equals -4 minus 5. So y equals -9, right? So at -2, why would they give you this graph when it's at -9? -2 would be, let's say that's -9. This graph, it will be a closed circle because -2 is included, right? Because it has those brackets. Okay. At 5, y equals 2 times 5 minus 5. That's y equals 10 minus 5. So y equals 5. So we have 5, 5. Did I do that correctly? So if it's excluded, what do I need to put up here? Open circle. Okay, it needs to be an open circle. So now I can put this line like that. Cool? Now I restricted my domain. Questions? No? When I see those sad faces, I get sad as well. All right. Oh, last one. I'm gonna try one. I'm gonna give you one. Okay. Try out number 9. It says to, for the given function and domain, draw the graph and identify the range using the same notation. We're not going to use the same notation. We're going to use interval notation. Okay. Okay. So plug in -6 here into my function. Y equals -1/2 times -6 plus 2. So y equals, what's half of 6? Negative and negative make a positive, so 3 plus 2. So y equals 5. So -6 and 5. Open or close circle? One for open, 2 for closed. I got both answers. 1 for open, 2 for closed. Don't look around. Be confident in your answer. 1 for open, 2 for closed. I'm gonna have an open circle 1. I'm gonna have a closed circle at that coordinate that I put. I don't even know the answer yet. Okay. 1 for open, 2 for closed. 2, 2, 1, 2, 2. I feel like I'm doing. What's that called? Morse code. Binary or binary. 0 and 1. Okay, I see more 2s than 1s. That's awesome. It is closed because it's less than or equal to. Okay, because it's less than or equal to, it's going to be a closed circle at -6, 5. Okay, x equals 2. If I plug that in, y equals -1/2 times 2 plus 2. So y equals, what is that? 1, -1 plus 2, which is 1. So I have 2, 1, open or closed? Anybody think it's closed? No, everything. Okay, so it's open. So since that's going to be open, we are going to put that guy with that guy, and we're done. Okay? Cool? Questions on that? I'm gonna skip 10. Okay, you don't have to do it. You can do it for fun. And you can show me. But that's the lesson for today. That's 1.1, guys. Okay, thank you.